All right, in this lesson we'll look at a lot of concepts that we've learned so far and then apply them in several word problems. And a lot of these problems have questions like questions on the AP test. Um, so, average rate of change on an interval, that is when we have an interval, a curve, or a function, and it's just going to be the slope of the secant line. And so that's just going to be the slope is f of b minus f of a over b minus a. And instantaneous rate of change is just going to be the derivative. Average value on an interval. The average value, if you have a function on an interval from a to b, the average value will be some y value that if you made a rectangle, the rectangular area would be the same as the curved area. And when you see average value of a function, you just have to remember to use 1 over b minus a from a to b. Speed is increasing or decreasing. Speed is increasing if velocity and acceleration have same sign, and it's decreasing if they have different signs. If velocity and acceleration have different signs, positive and negative, negative and positive, then speed is decreasing. If velocity and acceleration have the same sign, they're both positive or both negative, then speed is increasing. Total distance traveled is going to be the integral over the interval of the absolute value of velocity, and absolute value on a TI calculator, you go to calc, the calc button, you select math, num, abs, and that'll give you an absolute value. Position, you have to look at position at time b is going to be initial position plus the integral from 0 to b of the velocity. And yeah, so this would be initial position, that's the position at time 0, and then so we start at that initial value and add whatever the distance traveled over that interval is, or displacement over the interval. And then approximate the distance given velocity. If you have to approximate a distance given velocity, then you have to use area, find area using trapezoids or rectangles, and the questions usually specify which one. Well, in the AP test they always specify that. Calculator on an integral is using math 9, and the derivative is math 8. Alright, so here's a question. We get to use some of these strategies. So, part A, find their acceleration at 2 minutes. And so The key word is acceleration, but we also have to look at we definitely want to pay attention to that, but we also want to look at the levels of rates, and if we write down the units, the velocity is in feet per minute, and if we are trying to find acceleration, we know we need feet per minute squared, and this helps us confirm which calculus concept we're going to use. If we move down a level, we're finding a slope. So our strategy is just going to be the derivative of velocity, and v prime of this is going to be 10. The derivative of sine is cosine. We'll leave the inside the same, times the derivative of the inside, and then the derivative of 10 is 0. We're going to evaluate that at 2 minutes, so v prime of 2. If we put a 2 in there, we'll have 4 pi, and cosine of 4 pi is 1, so it's just going to be 20 pi, and that'll be in feet per minute squared. So also by doing the levels of rates, it reminds you of what units to use, because on the AP test they'll usually, well, they always will want you to have the correct units, and you get points for units. Okay, find the average acceleration from 2 to 4.25 minutes. Average acceleration. So keyword, average acceleration. Now we saw average rate. Average rate is a slope. Average value is an integral. And this is how we can tell which one to use. If we want the average acceleration, we look at this again, and we know that we're starting on feet per minute because that's what's given, velocity. And acceleration, we know we're moving down a level. So that means we need to use the average rate of change. We don't want to use the integral. We have to find the slope. And the slope is going to be v at 4.25 minus v at 2 over 4.25 minus 2. And that means we're going to plug 4.25, substitute 4.25 into that function, and then substitute 2 into the function, and we end up with 20 minus 10 over 2.25. So we end up with 40 over 9 feet per minute squared. Okay. Find the average velocity. Average velocity from 2 to 4 minutes. Average velocity. So our keywords are average velocity. And when we're looking at the levels of rates, we're starting on feet per minute, and it's asking us for velocity, which is feet per minute. So if you stay on the same level, that means, and it says average velocity, and we're staying on the same level, that means we need the other average value, the other average involved here, which is an integral. So we need for part C from 2 to 4. So it's going to be 1 over 4 minus 2 from 2 to 4. And then we'll integrate the velocity. And the velocity is 10 sine 2 pi t plus 10 dt. Okay. And we could work that out. Let's not take the time to do it. You can also do it on a calculator or on a phone, and we get 10 feet per minute. So the average velocity is 10. Okay, part D. Find the total distance traveled. So now keywords, total distance. And total distance. We're starting at velocity, feet per minute. We're trying to find distance, so that would be feet. We're moving up a level. To move up a level, we need to integrate. And total distance, just in case the golf cart is moving forward and backward, we're going to calculate the total distance forward plus backward. We're not going to just look at the backward movement as a negative. We take the absolute value. So in part D, we're going from 2 to 4 minutes, and we need the absolute value. And that turns out to be 20 feet if we did that on a calculator or a phone. Find their position. So now the key word is position, and we look back at position. We know that position is going to be an integral if we are given velocity, but we don't want to forget the initial position. So we know we're starting on level 1, feet per minute. We're trying to find position in feet. We're moving up a level, so that means we are going to integrate. We need the initial position, so let's look back at the problem, and we have to see their initial position is 5 feet from the lake. So we're going to have 5 plus the integral of the velocity, and that'll be 6 minutes. So we're going to go 5 plus the integral from 0 to 6 of the velocity function and we end up with 65 feet from the lake. All right, here's another problem, another different type of problem, and here they give us data rather than a function. So if you only have data with no function, that means you'll have to do a lot of approximations. With approximations, we're going to find average rate of change. We're also, when we have to find an integral, that means we're going to use rectangles or trapezoids. So here we have Jake is running from a tree, and it's 193 feet away from his house. He's starting 2 feet away from the tree, and then he's going to run to his house to avoid the Ice King, to avoid the snowballs thrown by the Ice King. So let's look at find his average acceleration. Here we have velocity, and we're looking for average acceleration. So average acceleration is the key word. We have the levels of rates, and we're starting on feet per second. Velocity, we're starting at feet per second. It's asking for acceleration, which is feet per second squared, That means we're going to move down a level. That means we need to find a slope, and it does say average, so we're going to be using the slope formula. We'll have velocity at 15 seconds minus velocity at 0 seconds over 15 minus 0. Here we get 17 minus 0 over 15. 17 over 15 feet per second squared. Velocity at 15 is 17, and the velocity at 0 is 0. All right. Part B, find his average velocity. So now we need to think. We know that that's the keyword, average velocity. And looking at the levels of rates, feet per second, we are starting at feet per second, and we're trying to find velocity, feet per second. We're starting on velocity, trying to find velocity, and it does the average, so that means we need to find the average value on an interval. We're going to use this formula, and we have to do 0 to 15, so that's going to be 1 over 15 minus 0, from 0 to 15, of velocity. We don't have a velocity function, so we need to let's use trapezoids. It didn't specify, we'll just use trapezoids instead of rectangles. And that means we're going to have 1 over 15, and then we have to find areas. Let's look at what the graph would be. And we have values of 0, 5, 10, 15, oops, 0, I was reading the wrong ones, 5, 17, and 3. Alright, so we need the velocity values, and I was reading the time values. So the graph is not to scale, but it won't matter. We have these values. We're going to draw trapezoids. Alright, so that means we need the area of this triangle. 1/2, base is 5, height is 15. Then we're going to do this trapezoid, which is 1/2. Let's do it like this. 15 plus 5 over 2 times the base, which is 5. Okay, then this area will be 5 plus 17 over 2 times the base, which is 5. And then we have 17 plus 3 over 2 times the base, which is 5. Alright, if we evaluate all of that, hopefully we get 9.5. And we are finding velocity, so that'll be feet per second. Average velocity. Alright. Let's look at C, total distance traveled. Keywords are total distance. And if we look that up, total distance means let's do the integral of the absolute value. So we also want to do, just check this, we're given velocity, feet per second, and we're trying to find distance. We're moving up, so that says we need to use an integral, and we're going to do the integral of the absolute value of velocity from 0 to 20 time, 0 to 20 seconds. And so now we can just use let's go back, and on this one we went 0 to 15, so make a correction here. That should be the right answer, but we wouldn't include that one because we're going to stop at 15, and that means we're not going to include that last trapezoid. So if you're hoping for extra credit for finding my mistake, sorry, I caught it. Hopefully I caught it, and I hope that's right. All right, so we have to find the absolute value of velocity, and in this case all the velocities are positive, but if they weren't, we would just reflect them to the make them positive and then find the area. So here we're going to do the same thing that we did before, but we just have to add that last trapezoid. So we have we can use the same graph, and it's really the same thing that we had before. We just won't have the 1 over 15. So this is going to be 1/2 5 times 15. 15 plus 5 over 2 times 5. 5 plus 17 over 2 times 5. 17 plus 3 over 2 times 5. And that'll give us the integral from 0 to 20. That should be 192. And we're finding feet, so we know that that is feet. All right. Part D, find his position at 5 seconds. And position is the key word. We know that position is measured in feet, but we're given feet per second. If we move up a level, that means we need to integrate. We're going to integrate from 0 to 5, integrate the velocity, but we forgot something. If we're going to find position, we need his initial position, and he starts 2 feet away from the tree. So it'll be 2 plus the integral, and that'll be 2 plus, let's look back at the graph, and we're going to go 0 to 5. We need the area of this, and we'll add 2 to it. So it's that triangle, 1/2, 5 times 15. And that gives us I'm going to say that that is 12 feet. I have something different in my notes, so maybe there's a mistake here, but hopefully not. All right. Part E. Will he reach his house in 20 seconds? So then we have to look back here, and we know that he traveled 192 feet in 20 seconds, even though that's absolute value. They were all positive anyway. He didn't move backwards at all. So he's going to travel 192.5 feet plus 2 for a starting position, and his house is 193 feet away. So because he started at 2 feet, he's actually gone 194 feet away from the tree. So he is going to reach his house. Because there was the tree, he started 2 feet away. His house is 193 feet to his house. and we know that he traveled 192 feet, 192.5. So he actually traveled 194 and a half, and that means he got into his house, which was 193 feet away. All right, last one. So here we're given a function for the height of a seat on a Ferris wheel. Let's find the vertical velocity. So part A, we know that velocity is the key word, and if we look at the levels of rates, feet, let's see, this is measured in feet, and we're going to find velocity, which is feet per minute, because this is measured in minutes. We're given feet, and we're trying to find velocity. Moving down a level means we need a slope. This is going to be an instantaneous rate of change, or the derivative. We need h prime of t. So we can find that with the chain rule. Derivative of cosine is negative sine. And we have to multiply by the derivative of the inside, 1.5 pi, and the derivative of 53 is 0. So then we have to substitute 2.5 because we want the velocity at 2.5, so h prime of 2.5 hopefully is alright. Part B, average velocity. Average velocity, and we have to be careful. We don't want to just always do the same thing when we see the word average. We have to look at whether we're moving up, whether we're moving down, or staying on the same level in these levels of rates. We're starting at position, we're going to velocity. If we need an average and we're moving down, then that's going to be the average rate of change, which was this slope formula. So that's just going to be h of 1.5 minus h of 0, 1.5 minus 0, and that is 9.673 feet per minute. Part C, find the average height. Average height. Average height is the key word. We're starting on height in feet, and we're trying to find the height. So we're staying on the same level, and it says average. So that means we need to use the average value of a function. And we can integrate from 1 to 3.5. 1 to 3.5. We will also do 1 over 3.5 minus 1, and we integrate this and we'll do that on a calculator, or why don't we just put I think these will all be approximate. Okay, is the vertical speed increasing or decreasing? In speed increasing or decreasing, so that means we look at this strategy. Increasing speed, velocity and acceleration have the same sign. Decreasing speed has different signs for velocity and acceleration. So we have speed increasing is the key word. We're starting on level 0 at position, feet. We're talking about speed. Feet per minute. So in this problem we need feet per minute. We also need feet per minute squared because we have to compare velocity and acceleration. So we'll do h prime at 2.1 and h double prime at 2.1. And if we did that on a calculator or phone, we'll get negative 106.969 feet per minute. And here we'll have negative 989.304 feet per minute squared. So we have both velocity and acceleration are negative. That means that the speed is increasing. Alright, and we'll stop there.